Hello everyone, welcome to the networking lab. Today we're going to cover one of the most important and practical topics in Cisco networking, VLANs. If you have ever been confused about how to set up VLANs, what a trunk port actually does, or why your inter-VLAN traffic doesn't route properly, this video is for you. By the end of the video, you'll be able to configure VLANs from scratch on a Cisco switch, set up trunk ports, route traffic between VLANs using a router, and most importantly, troubleshoot when something goes wrong. Here's what we are going to cover. There are 7 sections. We'll start with what a VLAN actually is, why you'd use one, and then we'll dig into VLAN types, how the 802.1q tagging standard actually works. That's the protocol that makes all of this possible. After that, we jump straight into the CLI, creating VLANs onto a Cisco switch, and then configuring access ports and trunk ports. We'll later cover inter-VLAN routing using a router on stick method, and then spend some time on troubleshooting. And we are going to close it with full verification commands cheat sheet that you can use as a reference. So what's a VLAN? VLAN stands for Virtual Local Area Network. It lets you logically segment a single physical switch into multiple independent networks without needing separate physical hardware for each one. Think about a company with one big Cisco switch. Without VLANs, every single device on that switch, either from sales department, finance department, IT, or guest Wi-Fi, all sit in the same broadcast domain. That means every broadcast packet gets sent to every device. It's noisy, it's inefficient, and it's a security nightmare. If someone on the guest Wi-Fi gets compromised, they can potentially reach your finance servers. So VLANs can fix this. You can divide one switch into isolated segments. VLAN 10 for sales, VLAN 20 for finance, VLAN 30 for, let's say, IT. Traffic in VLAN 10 cannot reach traffic in VLAN 20. So there are 4 benefits. The first is reduced broadcast traffic. Each VLAN is its own broadcast domain, so broadcast doesn't flood the whole network. Second, security. You can isolate sensitive departments from each other. Third, simplified management. You group users by function, not by which floor they are on or which port they are plugged into. And fourth, QoS, quality of service. So you can prioritize voice or video traffic on a dedicated VLAN. Before we configure anything, let's understand the 3 main VLAN types and how tagging protocol actually works. First, default VLAN. That's VLAN 1. Every Cisco switch comes out of the box with all ports assigned to VLAN 1. There's a best practice that don't use VLAN 1 for production traffic. It's well known and a target for VLAN hopping attacks. Create a new VLAN for your actual users and leave VLAN 1 empty. Second, the data VLANs. These are VLANs 22999. These are the ones you create for your departments. For example, VLAN 10 for sales, VLAN 20 for finance, and so on. You can assign switch ports to these manually. And third is native VLAN. This one's the most important. On a trunk port, any untracked traffic is assigned to native VLAN. By default, that's VLAN 1. You should change the native VLAN to an unused VLAN on all trunk ports, otherwise you are leaving a attacker vector open. Now, how does the switch actually defines which VLAN a frame belongs to. It uses 802.1q standard. When a frame travels across the trunk port, the switch inserts 4 byte tag right after the source MAC address in the Ethernet frame. The tag actually contains the VLAN ID. It's a 12-bit frame that supports VLAN numbers from 1 to 4094. Access port frames doesn't carry this tag, only the trunk ports does, so keep that distinction in the mind. Okay, now we are going to create VLAN on a Cisco switch on a packet tracer. Alright, let's get to CLI. I'm going to walk you through how to create VLANs and assign access ports step by step. Step 1. Create VLANs. Here I have a Cisco switch. Let's go to the CLI. Enter the global config mode and then use VLAN commands followed by VLAN number. So you go to terminal VLAN 10. Let's name it sales. VLAN 20. Let's name it finance. Okay, now we have successfully created two VLANs, VLAN 10 for sales, VLAN 20 for finance. Giving VLANs meaningful names is a good habit. When you are looking at a show VLAN brief 3 months from now, you'll easily remember which VLAN is for what purpose. Then step 2. Assign an access port to a VLAN. Navigate to the interface and select the switch port mode to access and then assign it to the VLAN. Okay, now go to global mode again, interface, fast Ethernet 01, switch port mode access, and now we assign VLANs. So we have created VLAN first and then assigned a switch port, a specific VLAN. A really important tip here is that always create VLAN before assigning to a port. If you assign a port to a VLAN that doesn't exist in the database, port goes into an inactive state. It won't pass traffic. After configuring, always verify using show VLAN brief. Show VLAN brief. So you can see we have two VLANs. One is sales VLAN 10 and we have assigned a switch port already, fast Ethernet 0.1/1, and then we have VLAN 20 for finance and we didn't assign any switch port. Now let's talk about two types of switch ports, access port and the trunk port. An access port carries traffic for exactly one VLAN. That's it. It's what you connect end devices to, for example PCs, IP phones, printers, etc. The frames that comes out of access ports are untagged. That is, there's no 802.1q header. The device on the other end has no idea what VLAN it's on. Configuration is just two commands that we have already tried. Switch port mode access, that means it's an access port. access port mode, and switch port access, and then VLAN and VLAN ID. A trunk port, on the other hand, carries traffic for multiple VLANs simultaneously. This is what you use between switches and between a switch and a router. The frames on a trunk port are tagged with 802.1q VLAN ID, except for native VLAN, which travels untagged. The configuration is very simple again: switch port mode trunk, switch port trunk allowed, VLANs, and then VLAN 10, 20, etc. The second command is most important. It explicitly controls which VLANs are allowed across the trunk. If a VLAN isn't allowed in that allowed list, its traffic won't cross the trunk link. That's a very common troubleshooting scenario. So one of the best practice worth mentioning here is always explicitly set trunk ports and disable DTP, which is Dynamic Trunking Protocol, by adding switch port no negotiate. DTP is enabled by default and will try to negotiate trunking automatically, which is a security risk, so that's why you should always turn it off. So here's one fundamental thing about VLANs. They're isolated by design. A device in VLAN 10 cannot talk to a device in VLAN 20 unless the traffic passes through a layer 3 device, for example a router. The classic way to do this is on a router is called router on a stick. You can take one router interface, run a trunk link between switch to the router, and then create sub VLANs on the router, one for each VLAN. Okay, so let's try on the Cisco packet tracer. So I have one Cisco router and a Cisco switch, and okay, so on CLI we go to the global mode, and then the interface is gigabit and 0/0 and .10. So you see we are into the sub interface. So encapsulation dot 1q 10 for VLAN number 10, and IP address 192.168.10.1 255.255.255.0. Okay, so we've created one sub interface, and that points to VLAN 10. Now if you want to create another one, okay, let's try another one. Interface gigabit 0/0/20 encapsulation dot 20 IP address 192.168.20.1 255.255.255.0, and that's it. So we have created two sub interfaces. The dot encapsulation dot 1q10 command tells the router which VLAN ID to tag or accepts on each sub interface. The IP address on each sub interface becomes the default VLAN for the devices in that VLAN. So a device in the VLAN 10 sets its default gateway to 192.168.10.1. A device in VLAN 20 sets its default gateway to 192.168.20.1. So when VLAN 10 wants to talk to VLAN 20, the traffic hits the router, gets routed, and comes back to the VLAN 20. So this method is called router on stick because all the inter-VLAN traffic rides up and down through one physical link. So you see there's just one physical link, and it's where the both the VLANs we have configured for the traffic flows through the same link. This type of scenario is not suitable for the production environments, but for the testing purpose or for CCNA exam preparation, the router on stick is all what you need. Now we just need another one step, because you see the link is down. Now we need to go to the interface again, /0 and no shutdown, which means, okay, so you see both the sub interfaces, for example 0.10 and 0.20 is up. Okay, so you can see the link status is up now, and let me show you some more details. Okay, you see Gigabit Ethernet 0/0.10 is a sub interface. It has the link status up, and an IP address is assigned 192.168.10.1/24, and similarly Gigabit Ethernet 0/20 is another sub interface. The IP address is 192.168.20.1/24. The link status is up. So if a VLAN 10 traffic should go up to the router, it goes via Gigabit Ethernet 0/0.10 subinterface, and if the VLAN 20 traffic goes up from the Cisco switch to the router, it goes via subinterface 0/0.20. So this is how router on a stick works. Okay, now let's talk about troubleshooting. This is where exams and real life intersects. I've organized 4 most common VLAN issues as symptom and fix pairs. Issue number 1. The devices on the same VLAN can't communicate. Check the basics first. Show VLAN brief. That's the command you need to run on the switch and confirm the VLANs are listed and show as active. Then confirm the port is in the right VLAN. If the VLAN shows as inactive, it doesn't exist in the database, so you need to create it. Okay, then there's issue number 2. Inter-VLAN traffic isn't routing. This is the most common issue. This is almost always misconfigured subinterface. So run show IP interface brief and look at your subinterfaces. They should show as up and up, just like we did in our previous example. So if I run show IP interface brief, so you see the status is up. Okay, so issue number 3 is trunk port not passing VLAN traffic. This is usually one of 2 things. Either the VLAN isn't in allowed list on the trunk. So you need to check show interfaces trunk and look at the VLANs allowed and active section, or you have a native VLAN mismatch. So both sides of the trunk needs to agree on which VLAN is native. If there is a mismatch in native VLAN, all kinds of weird problems can occur. And the last, not least, issue number 4. The port shows as inactive. This is the assigned to a non-existent VLAN problem that I mentioned earlier. So run show VLAN brief on the Cisco switch and find missing VLAN. So you need to create one. So the golden troubleshooting rule is work from layer 1 up. Is the port up? Is the VLAN active? Is the trunk passing the right VLANs? Is the routing configured correctly? So one step at a time. And finally, we have a verification commands cheat sheet. Let's look into the verification commands. So there are 6 commands you'll use every time you configure or troubleshoot VLANs. So show VLAN brief. It lists all VLANs, their status, which ports are assigned. If something looks wrong, start here. Show VLAN ID, and then the VLAN ID itself. Deep dive on a specific VLAN. Show ports, status, VLAN type. Useful when you need details on one VLAN without the noise of full list. Show interfaces trunk, the trunk command. So this one, it shows all trunk ports which VLANs are allowed, the native VLAN, which VLANs are actively forwarding. This is your go-to command for trunk related problems. Show interface, and then the interface itself and switch port. So it shows everything about a specific port, its mode, administrative VLAN, operational VLAN, trunking status. So use this whenever you are not sure what a port is actually doing. For routing, show IP interface brief for inter-VLAN routing. So you can use this command on a router. It shows the status of all interfaces, including sub interfaces. Up and up is good. Anything else needs to be investigated. And finally, show running config and pipe section VLAN. Super useful short command. It filters the running configuration to only show VLAN rated lines. It's great for a quick audit without scrolling through the whole config. And that's a full run through of VLANs on Cisco switches. Let's do a quick recap. You know what VLANs are, the 4 reasons why we use them, which is security, it reduces broadcast, flexible management, and QoS. Now you need to understand VLAN types, how 802.1 tagging actually works at the frame level. You can create VLANs, assign access ports in Cisco switches. You know the difference between access and the trunk ports and when to use each of them. You can also set up router on a stick inter-VLAN routing, and you have a systematic approach to diagnose the most common VLAN problems. So this is generally one of the fundamental topics you will come back to over and over again if you're studying CCNA. So make sure to do the full configuration from memory, create VLANs, assign access ports, configure trunks, set up sub-interfaces, and practice it in the Cisco packet tracer until it's automatic. If this video helped you, please like and subscribe. See you in the next one.